Welcome to July's Leetcode challenge. Today's problem is threesome. Given an array nums of n integers, are there elements a, b, c in nums such that a plus b plus c equals 0? Find all unique triplets. The solution set must not contain duplicate triplets. So that's actually a big caveat here. If I'm being honest with you, I've solved this problem before. I actually even have a video for it. So when I first saw it, I thought, I've solved this before. I can do this. It's going to be easy. And then I ended up spending another hour on this. So that was a real gut check to me. I need to stay humble because these problems are really hard. Now, here, with the example that they gave us and the hints that they give us, it all kind of points to using a hash map and using the two-sum solution. And if you remember with two-sum, what we do is create a hash map to figure out what the target value is that we need to get the number 0, and then just add whatever index number from before that into our output. And that works fine. That would even work here as long as we do it in a nested for loop. But the problem is we have duplicate numbers. So with duplicate numbers, that approach doesn't work. Like, what happens if I check to see like -1, 0, 1, that counts as one of the answers. When I check 0 next, now I'm going to check for -1, 1 as well, and that, because the ordering is different, is going to also be added into the output. So that's a big problem. How can we avoid that? Well, one way you could do that is by sorting the answers that you figure out and check to see if it exists inside some sort of hash. But that's really inefficient, right? Because each time you find a triplet, you need to sort it. Then you'll need to like convert it to a string or a tuple, and then check a set to see if it exists. And that just doesn't work. It's gonna reach a time limit exception for this problem. So one way we could avoid that problem to some degree is to sort it. And if we sort it, it's gonna look something like this. Is that right? 1, 1, 2, and that helps in a way, but it still gives us another problem, because if we sort it, now the ordering is going to always be the same, so that's good. But if we have duplicate numbers, say we check here with -1, and then we say, all right, 0, 1, this counts as an answer. Now when we check for -1 and we go to the next 2, it's going to check again to say, oh, -1, 0, 1, that also counts. So we'll have to do the same thing. We'll have to have some sort of hash to keep track of all these triplets. And that, again, is just really inefficient, especially if you have an input like with all zeros, let's say like a million zeros. Well, then each time you check for all the triplets, it's going to say, well, this is 0. Okay, check to see if it's in our hash map. Oh, it's in there. Okay, next time, oh, 0, 0, that too. And it's going to do that every single time. So if you have like a list of all zeros, that's never going to... it's going to be really, really inefficient. So that was the big problem for me. I kept on trying to use hash maps of different sorts and kept getting time limit exceptions. So forget hash maps. You don't need hash maps. What you can do instead is start with like one pointer. Start with like a for loop and point to one of the numbers, like 0, like here. And just have like a left and right pointer checking for all the other numbers once it's sorted. Because once it's sorted, what we can take advantage of is say, hey, if the sum of whatever these 3 numbers are, if it's greater than 0, then we know that we want to move our right pointer to the left, because we want to find a smaller number. If it's less than 0, then move the pointer to the left pointer to the right. And just continue that until we reach a point where left is no longer less than the right pointer. And really that's it. And the next try for the next one, have the left pointer here and the right pointer. But the big trick is when we check our left and right pointer, one thing we want to make sure of is have we had this pointer point to the same number before? Because if we have, there's really no reason to check that again. Like say that we check at this point and we have the left pointer and it's like both zeros. We don't really need to have this left pointer try out the next 0 here. because we've already tried 0. So why do we need to check that? We just need to continue on until the number is different, right? And that's going to be the trick. Because we sorted initially, we could just know how to move our pointers and make sure that whatever 2 pointers we've been pointing to, we haven't already checked this one before. Because if we have, then there's just no point in doing it again. So just skip that and move our pointer, right or left. Okay, so hopefully as I code this out, it'll start making sense. Let's first initialize an output and sort our nums. And really, I don't see a way of really avoiding that. To get this optimized, we have to sort our numbers. So we'll just say A in range of what? Length of nums. And we want to make sure that we're not going to be checking the one on the very, very end, because these left and right pointers need to be pointing to the rest of the output. So I believe we can do it like this. And what we'll do here is, first off, we'll check to say, hey, if nums A is greater than 0, then just break the loop. Because if our very initial first pointer is pointing to like a 1, everything else is going to be greater than 1, right? So how are we going to have a triplet that is going to equal 0? It's not going to happen. So we can just break our loop, get out of here. Next, we want to say, we want to make sure that these pointers aren't going to be pointing to the same thing again. So if A is greater than 0 first, and nums A equals nums A minus 1, then just continue, because we've already checked this number before. We don't need to do it again. All right, so now we can start creating our pointers. Have a left pointer and right pointer to the A plus 1 and I guess the length of nums, right? Oh, it's actually length of nums minus 1 because of the indexes, right? So while we have L minus R, we'll first check, okay, is the nums A plus nums L plus nums R, is this what? Less than 0. Because if it's less than 0, then we want to move our left pointer 1. Okay? So we'll put an if here, if nums. Okay, otherwise, else if it's greater than 0, then we want to try to lower the number. So we'll say actually decrease left pointer, or the right pointer. Okay, great. Otherwise, it equals 0. So great, we found one of the answers. So let's add this answer to our output. We're going to just append and say, make a list of nums, what? A and nums L and nums R. All right, so here's the tricky part. Oh, what did I do wrong here? Make that a list, of course. Okay, so we've added this output, but now we don't want to ever check. We want to move our left and right pointers to numbers that we haven't seen before, right? Because we don't want to check again the same number. Otherwise, we might end up adding a duplicate. So while L is less than R and nums L equals nums L minus 1, increase RL. God dang it. Okay. And the same thing on the other side, but we're going to be checking for the right. We'll say if it's the same number as before on the right pointer, continue it. Otherwise, we just move both our pointers once that's finished. Okay. So now we should have our output. Is there anything I missed? I think we can, I don't think so. I think we can just return our output. So let's see what that gives us. Let's add a range. Oh, okay. Okay. Right, because this right pointer is going to be out of index. Oh, okay, so is it -2? What am I doing here? -2 maybe? Okay, so nope. Looks like I'm not getting the right answer here. Okay. What am I doing wrong? I might have flipped that around here. Let's see if it's like that's what it meant. Okay, so it looks like that is going to work. Let's just submit that. Okay, so there we go. It's accepted. Sorry about that. I guess what you're doing is checking for the next one, not the previous one, and that's totally fine. Yeah, so this is my efficient solution. I haven't found anything really better than this. Maybe there is one using hash maps, but everything I tried using hash maps was either time limit, exceeded the time limit, or just was so hard to understand it wasn't worth it. So yeah, thank you very much.